Now let's start the last part of laser. Lasers can be classified in many different ways. One is by classifying them into continuous lasers and into pulse lasers. In continuous laser, the laser output is constant, meaning you'll see the light there and it will not flicker. In pulse lasers, you can imagine the light to be flickering on and off, on and off, and on and off repeatedly. However, because this rate of on-off is very fast, usually in the time of nanoseconds, you might not see the pulses. However, we still call this pulse lasers. Lasers can also be classified by their energy levels, class 1 being the least dangerous and class 4 being the most dangerous. If a laser has a power rating P and puts out pulses of average time T, the energy per pulse will be given by Pt. If the laser light has a wavelength lambda, then the number of photons per pulse will just be the total energy divided by the energy per photon. This is given by this equation here. So, example 1, a particular ruby laser produces a pulse of laser light that exists for a duration of 1.2 millisecond. If the average power of the laser is 3.6 milliwatts, how many photons of light of wavelength 694 nanometers are emitted by the laser? So first, we found the energy per photon by using E equals hf. We plug in the numbers and we get the answer of 2.87 times 10 to the power of 19 joules. We then found the energy per pulse of the laser, which we take by using power times the time in which the pulse is present, and we found it to be 4.3 times 10 to the power of 6 joules. We then calculate the number of photons by taking the total power in one pulse divided by the energy per photon, allowing us to calculate the number of photons to be 1.5 times 10 to the power of 13 photons in that one pulse.